Example number 2. If a rod or piece of wire is homogeneous, then its linear density is uniform and is defined as mass per unit length, pro equal mass over length, and measured in kilograms per meter. Suppose, however, that the rod is not homogeneous, but that its mass measured from its left end to a point x is m is the function of f of x. So we know that the mass of the part of the rod that lies between x1 and x2 is delta x equal f of x2 minus f of x1. So we can calculate the average density is delta m over delta x, that is f of x2 minus f of x1 divided by x2 minus x1. The linear density pro at x1 is pro equal the limit of delta m divided by delta x as delta x approaches to 0. This is the derivative of mass with respect to length. Let's suppose that the mass is a function f of x and equal to square root of x, where x is measured in meters and m is in kilograms. Then the average density of the part of rod given by between 0.1 and 1.2. So we want to calculate the average density. So the average density is the delta m divided by delta x, which is f of x2 minus f of x1 divided by x2 minus x1. So in this case, our x1 is 1 and our x2 is 1.2. So we calculate the average density is delta m divided by delta x is equal f of 1.2 minus f of 1.2 minus 1 in the bottom. So we plug these two numbers into the function. So we got 1.2 square root minus square root of 1 and 1.2 minus 1. And we calculate this number. 1.2 minus 1 in the bottom is 0.2. And we calculate this number, we get 0.48 kilograms per meter. And if we want to find the density right at x equal to 1, so the density at x equal to 1, so we will use this formula. Is we just take the first derivative of the function m. So the function m is equal f of x equals square root of x. So we find pro by taking the m over the x with respect to x. So we take the square root of x prime, and it's equal to x to the 1/2 prime, and we have 1/2 x to the negative 1/2, and that is 1 over 2 square root of x. And we evaluate this at x equal to 1. Then we got the answer is 1 over 2, which is 0.5 kilogram per meter. So we have two answers. One is the average density and the other is the density right at x equal to 1. The difference between them is that if you draw the graph and the square root of x is like this. So let's take x equal to 1 right here, and then let's suppose that we have 1.2 right here. So we have the density right at x equal to 1 is the derivative, so that is actually it's just the slope of the tangent line. So this is pro, and we find the average density. So that is the point 1.2. You connect the point 1 and 1.2. So 1 and 1.2, you get a blue line, and the blue line is the secant line. And the pink line is the tangent line. So that's why it shows the difference. Because the first one, the difference between the 2 points is 0.2. Okay, and that is the slope of the tangent line, but the slope of the secant line. But the density right at x equal to 1, when we take the first derivative, is give us exactly the slope of the tangent line. So it will be more exact answer than the average density.